Hello everyone, myself Ashit Desai, Assistant Professor, Solutions of Technology, College of Engineering. Today we are going to discuss the integration of additive manufacturing with IoT. So in that session we are discussing the part first, which is included the Industry 4.0, how it can be revolved and what are the different advantages which is using for the Industry 4.0 with the 3D printing. So whenever we're discussing the Industry 4.0, that revolution is use of artificial intelligence, then which has having IoT, then blockchain, big data, and 3D printing. And there are different types of technology to enable the better and smarter, sustainable, and more efficient process. So for this purpose, we have to save the time, reduce the wastages, and enhance the efficiency and safety. Also, we can increase the profit and to stay competitive globally. So these are the main aim of the Industry 4.0. So whenever we discussion of the Industry 4.0, so we are having the digital technology innovation, that is first we are discussing with first generation, so how it can be come up the the word that is Industry 4.0. So we'll discuss the first Industry 4.0. In that, the first of all, the mechanization, water power, steam power we are using, and then where mechanization will take place. So this is about the first generation. Second generation, we have use of the mass production. In that, we are using the assembly line, and then use of many more use of electricity. So we are conveniently go for the Industry 4 2.0. After that, the revolution we carried, and we are taking the help of computer and automations. We get the maximum production and better and efficient processes. After that, we are adding the cyber physical system, like we discuss about the cyber security, then machine learning, big data analysis, then horizontal vertical integration of the cloud computing, and many more AR and VR. So this technology we are integrating with this, and we created the dehumanization of industrialization and environmental degradation. So these aim are the for the Industry 4.0. So now we are going to discuss the next point. So actually the use of Industry 4.0 to save the time, reduce the wastages, and enhance the safety, and the increase in the profits. So these are the main motto for the Industry 4.0. So look at the next, whenever you adding this technology, so in that there is also representing as a 3D printing also. So this, that is nothing but additive manufacturing. So additive manufacturing is nothing but layer by layer manufacturing, and which is useful in the manufacturing sectors, which is enabled to sustainable technology with an aim, and enables to growing needs and fulfill the new requirements. So that is about the main motto. Also, we are relating with the cost equality and sustainability. So actually, the aim of the 3D printing is we have to create the complex geometries. Also using different prototypes like aerospace industry, healthcare industry, and automotive industries. There are different components. Actually, we are in the impacting of additive manufacturing. So in this, design flexibility is there, then wastage reduction is there, then industry applications like whenever there is are there, and the production time reduction will be there. So this is about the main components of the additive manufacturing. So whenever we are getting the complex geometry, we have difficult to manufacture this component, so because of different aids. So that's why we are using the 3D printing, and we are formulating the design flexibility. Then next, we are reducing the wastage also, because we are required only materials should be adhere over there. Wastage is less, so that's why waste reduction is possible through the additive manufacturing. Also, we are the production time will be getting late, but if you get the speed up in the process, that is also impactable by using this Industry 4.0. The creation, also the sustainable manufacturing, the creation of manufacturing products using processes that minimizing the negative environment impact, conserves energy and natural resources, are safe for employees. It should be considered as a economical sounds, and then it should be manufactured over there. So additive manufacturing is important tool for the Industry 4.0, and it is an important technique for the advanced and sustainable manufacturing. So now discussing about the additive manufacturing, it is also called as 3D printing, but in the next key is about the Industry 4.0. This is why we are creating this customized products, as well as we get the greaterly complex geometry. Also, we are getting the decentralized manner the production process will starts, and reduce the transport distances and inventory maintenance cost. So also we are reducing this by 3D printing, because if it is the part is not available with a industry, we can formulate it by the 3D printing, and we can get the less within less cost, and we are required reduction in the transport distances also. So this is the benefit of the manufacturing. So here, this additive manufacturing, there are three areas we are classified mainly, that is liquid based, powder based, and solid based. One is the stereolithography, that is on liquid base. So one by one we'll discuss here. So liquid base means stereolithography. So whenever the liquid resins are present, so we can call it as a stereolithography. Powder base means what? Selective laser sintering. So it is about laser which is coming under the metal powder, and then working will be there. So that is about the selective laser sintering. Then solid base. So here the filament is there, and it should be dropping because of the different temperature effects, and then after that we can formulate our components. So this is the forming areas we are designing in the additive manufacturing process. And then nextly we are discussing in the types of processes. So first is fuse deposition method. So here we are getting in a spool, and then we are getting into the nozzle. So after that, after fitting, we can get the metal form, and then we can get the this layer by layer manufacturing, that is about the reprinting. And here the table is goes down. Suppose first layer is completed, so this is there are different layers we can crystallize over here, and then it can be manufacture our components. So this is about the fuse deposition method. Then nextly we are having stereolithography. So here there is a container with having liquid resin, and the laser source will be coming under this, and then it after that X scanning mirror, it can be reflected, and then object should be formed. So this is about the liquid resin, and fuse deposition method is solid resin, solid form. So solid form of material. Then selective laser sintering, here powder material is there, and here the roller we can roll after that completion of laser scanning, and then we can complete this the component. So this is about the built up area we can develop in a processes. Then nextly, that is about fused deposition method, that is FDM. So this is about 3D model. We are converting, actually this 3D model we are creating a software that is like Fusion, or you can say any type of 3D software that is like a that is called we can say SolidWorks, Katia. So like that we can make a software. So here we are making the object holder, that is called as 3D model. After that we are serve in a different software, that is conversion for the STL, that is standard triangle language conversion, we can possible over there. After that we make slicing, and then the tool path will be generated. So this is the kind of actions we'll get in the it is in the form found. Then next after that we can get the final part, and then we can manufacture this component. So likewise the fuse deposition method is possible, and then we can get the required area. The next is about the theme under that is challenges in our FDM technology. So we are discussing only FDM technology over here. So here the challenges which is faced in FDM technology. This is FDM technology, and this is the formations we are required the tooling path, and then also generate the final part will be possible over here. The next is about where challenges which is faced in 3D printing. It is in FDM technology. So first is printing speed, then slow layering process, then inefficiency mass production, then reduction in the size, restrictions, visible layer lines, limited printer size, then need of frequent calibrations, then inadequate material properties, and then restricted material types. So these are the limitations we are facing in a 3D printing. Then we are using after that we are getting these issues, we are getting into the of IoT. So IoT is nothing but a network of connected sensors and devices for real-time data collection and automation. So we are collecting the real-time data, and we are automate the system. So here we are getting number of sensors data we required over there, and then we can solve these problems which is either available in a FDM. So first of all, we integrate with the automation, that is with the additive manufacturing. This is enhancing the automation, predictive maintenance, and process optimization. So this is the three area we are discussing with the IoT. Then nextly we are discussing about the sensor in AIM, that is about additive manufacturing. This is a different sensor for the temperature sensor for monitoring and regulate the temperature for optimal settings. Then pressure sensor ensure the consistent extrusion pressure for quality points. Then vibration sensor detect and alert to mechanical misalignment issues. Then optical camera sensor, we can provide the real-time monitoring and defect detection. So these are the sensors we are providing over there. Then proximity sensor, the facilitate for auto bed leveling and precise print head positions. These are the sensor which is useful for the 3D printing, and we're getting the data in a one panel, that is we can call it as a IoT sensor technology. So this is about the main benefit of that system or that sensors. Then nextly we are discussing about the next part, that is about enhancing 3D printing with the aim, that is integrations part, that is print. So these are the different sensors we can solve this effective work. Suppose problem in a printer speed, the real-time monitoring optimization print panels to increase the speed. So we are getting the real-time data, and then we can solve this problem of printing speed. Then material limitations, so adjustment, real-time adjustments we can monitor over there, and then we can use the smart material management system. So here is also problem. Resolution solves, so we are auto adjustments we can do over there, and quality print will be take place. Size restrictions, so for mounting or monitoring the print for the management to large objects, so we are managing the large objects into size restrictions, but we are available with a different type of sizes printers we can develop over there. Then wrapping and shrinkage, so here temperature and environment control to reduce the wrapping and shrinkage. Then post processing, that is about automation processing takes task and condition monitoring. So printing calibration, so auto calibration we can do with the IoT system. Environmental and health concerns, so this is about air quality monitoring and emission tracking for safety. Also we can do over there limited material monitoring, so we can manage the multi explorer system and seamless material switching. So this is about the integration of IoT. Then nextly benefits, when are very different benefits are there. Remote monitoring is there, automated control, quality control is there, energy efficiency is there, integration with digital twins, smart material management and predictive maintenance. So that can be possible, which is help with the additive manufacturing. So whenever you integrate with the IoT and additive manufacturing, so will they get the different type of advantages. So these are the different advantages we can get the informations, and we can monitor all the systems with they get exact output and input. Then nextly we are discussing about the difference between the traditional 3D printing and IoT based 3D printing. So in monitoring, in a traditional way is manual observation. In IoT based, real time cloud monitoring is there. Maintenance purpose, if you compare with this, then reactive and predictive maintenance will be there. So here break fix is there. So that means what break is where more in a traditional printers. Quality control, so post processing inspection is required. Here AI driven real time defects detection is there, that is why not required process that post process inspection. Then connectivity, that is standalone operations, it is remotely operated by this IoT system. Energy use, continuous operation is there, and smart energy management, which is evolved in IoT enabled 3D printers. Then material tracking, manually filament check, but here automatic filament monitoring and feeding is there. So that is about IoT enabled 3D printers. So these are the contents we are discussed with the traditional as well as IoT 3D printing. So limited efficiency and quality is evolved in a traditional 3D printing. IoT based in 3D printing is enhance the efficiency and quality. So these are the main area we are discussing in the 3D printing. So whenever we are going to industry 4.0, the big issue is in manufacturing areas, because various complex geometry is available, and if you're having the problem in a machine, so also we can solve by the IoT system. So that's why we are IoT integration system with the industry 4.0. So it can provide many solutions to the system, and then we are getting the different causes we can find over there by the IoT, because it can be secure the real time data, and after that we can get the collectively we can work over there. So this is about the advantages and benefits of the 3D printing with integration of IoT. Thank you.